Time is perhaps the most fundamental yet mysterious concept that governs every aspect of our existence. Right now, as you listen to these words, time is flowing around you like an invisible river, carrying you forward through moments that will never return. You feel its passage in the beating of your heart, the rhythm of your breathing, the gentle pull of fatigue as evening approaches. Yet, for all its intimate presence in our lives, time remains one of the most profound puzzles in all of human thought. Hey there, how was your day? Wherever you are in the world, I'm grateful you're spending this moment here. Feel free to comment your time and location below. It's always amazing to see when and where we're all watching from, or gently drifting off. In this video, we're going to explore something we all experience, but barely understand. Time. What is it? Where does it come from? Why does it move forward and never back? You'll discover how scientists define time, how we measure it, and why Einstein showed us it may not be as constant as we think. The visuals are here if you'd like to watch, or you can close your eyes and let the story unfold. Let your thoughts slow down. And let's begin. Consider this remarkable fact. Every single moment of your life exists within time, yet you cannot step outside of it to observe what it truly is. You are like a fish trying to understand water, or a bird attempting to comprehend air. Time is not just the stage upon which your life unfolds. It is woven into the very fabric of reality itself, inseparable from space, matter, and energy in ways that challenge our deepest intuitions about the nature of existence. The ancient Greeks had two words for time that capture something essential about its dual nature. Chronos referred to chronological time, the mechanical ticking of clocks, the measured progression of seconds, minutes, and hours. But they also spoke of kairos, which meant the right time, the opportune moment, time as it is experienced rather than simply measured. This distinction hints at something profound. Time is not merely a dimension through which we move, but a lived experience that shapes our consciousness and gives meaning to our existence. Throughout history, humanity's relationship with time has been one of endless fascination and perpetual mystery. The ancient Mesopotamians gazed up at the night sky and saw in the wheeling of stars and planets a cosmic clockwork that could measure the passage of days and seasons. The Egyptians built monuments aligned with celestial events, creating calendars carved in stone that would outlast empires. The Maya developed mathematical systems of extraordinary precision to track cycles within cycles, understanding time as an intricate web of overlapping patterns that stretch back to the creation of the world and forward to its ultimate transformation. But what is time really? Is it a fundamental property of the universe, as basic as space or energy? Or is it perhaps an emergent phenomenon, arising from more fundamental processes like the tendency of systems to move from order to disorder? Is time linear, flowing in one direction like a river toward the sea? Or could it be cyclical, returning again and again to the same moments in an eternal dance of repetition? These questions have captivated philosophers, scientists, and mystics for millennia, and the answers we've discovered are far stranger and more beautiful than our ancestors could have imagined. Isaac Newton, that towering figure of the scientific revolution, conceived of time as absolute and universal, flowing uniformly throughout the cosmos like a great cosmic river. In Newton's universe, time was the same for everyone, everywhere, a fixed backdrop against which all events played out. A second on Earth lasted exactly the same duration as a second on the most distant star. This was time as a stage, empty and unchanging, upon which the drama of physics unfolded according to mathematical laws of perfect precision. For more than 2 centuries, Newton's conception of absolute time reigned supreme. It matched our everyday experience perfectly. When you arranged to meet a friend at noon, you both understand that noon means the same thing regardless of where you are. When you watch a movie, you expect the story to unfold in a logical sequence from beginning to end. Time seemed as solid and reliable as the ground beneath your feet, as predictable as the sunrise, as constant as the northern star. Yet even as Newton's clockwork universe ticked away with mathematical precision, cracks began to appear in this seemingly perfect edifice. The speed of light, that fundamental constant of nature, refused to behave as Newton's theory predicted. Light traveled at the same speed regardless of whether its source was moving toward you or away from you, a fact that made no sense in a universe where time was absolute and space was fixed. It was as if the universe itself was whispering that something deeper was at work, something that would require a fundamental reimagining of the very nature of reality. Enter Albert Einstein, a young patent clerk in Switzerland who possessed one of the most revolutionary minds in human history. Einstein's great insight was to take the constancy of light's speed not as a puzzle to be solved, but as a fundamental fact about the universe from which everything else must follow. If light always travels at the same speed, he reasoned, then space and time themselves must be flexible, stretching and compressing to accommodate this cosmic speed limit. The implications of Einstein's insight were staggering. Time, it turned out, was not the rigid, universal backdrop that Newton had imagined. Instead, it was elastic, malleable, intimately connected to space in a four-dimensional fabric that Einstein called space-time. Time could slow down or speed up depending on how fast you were moving or how strong a gravitational field you found yourself in. The faster you traveled through space, the slower you moved through time. The stronger the gravitational field around you, the more time dilated, stretching like taffy under the influence of massive objects. This wasn't merely theoretical speculation. Einstein's predictions have been confirmed by countless experiments and observations. Atomic clocks flown on airplanes tick at slightly different rates than identical clocks left on the ground. The global positioning system that guides your phone's navigation must constantly correct for the fact that time runs slightly faster on satellites orbiting high above Earth's surface. Particles accelerated to near the speed of light in giant colliders live longer than identical particles at rest, their internal clocks slowed by their tremendous velocity. Perhaps most remarkably, Einstein showed us that the present moment, that knife edge of now that seems so immediate and universal, is actually relative. Events that appear simultaneous to one observer may occur at different times for another observer moving at a different speed. The universe, it seems, has no universal now, no cosmic clock that ticks the same for everyone. Instead, each of us carries our own time, our own personal rhythm through the four-dimensional symphony of space-time. But Einstein's revelations about time were just the beginning. As physicists delved deeper into the quantum realm, they discovered that time becomes even stranger at the smallest scales of reality. In the quantum world, particles seem to exist in multiple states simultaneously until the moment they are observed. The very act of measurement appears to collapse these quantum possibilities into a single, definite outcome, suggesting that consciousness itself might play a role in the unfolding of time. Quantum mechanics reveals a universe where cause and effect become blurred, where particles can be entangled across vast distances, instantly affecting each other in ways that seem to transcend the normal flow of time. Some interpretations of quantum theory suggest that all possible histories of the universe exist simultaneously, with consciousness somehow selecting which branch of this infinite tree of possibilities we experience as the flow of time. The arrow of time, that fundamental asymmetry that distinguishes past from future, emerges most clearly in the realm of thermodynamics. The second law of thermodynamics tells us that entropy, the measure of disorder in a system, always increases over time. A hot cup of coffee cools down, never the reverse. A broken glass never spontaneously reassembles itself. Memory allows us to recall the past, but not the future. This thermodynamic arrow of time gives direction to our experience, creating the flow from past to future that shapes our consciousness and our understanding of causality. Yet even this seemingly fundamental principle raises profound questions. Why did the universe begin in a state of such low entropy that it could increase for billions of years? What gives time its direction, its relentless forward march? Some physicists speculate that time itself might be emergent, arising from more fundamental processes at the quantum level. Others suggest that time might be cyclical on cosmic scales, with the universe expanding and contracting in an eternal rhythm of creation and destruction. The mystery deepens when we consider consciousness and its relationship to time. Your subjective experience of time is remarkably fluid, stretching and contracting based on your emotional state, your level of attention, your age, and health. A moment of crisis can seem to last forever, while hours of deep concentration can pass in what feels like minutes. Children experience time differently than adults, their days stretching endlessly while their years fly by in a blur of growth and discovery. Neuroscientists have discovered that our brains construct our experience of time from multiple sources: the rhythm of neural oscillations, the accumulation of memories, the anticipation of future events. There is no single time center in the brain, no master clock that keeps track of duration. Instead, our sense of time emerges from the complex interplay of memory, attention, and expectation, creating the rich temporal texture of consciousness. Some philosophers argue that time is not a feature of the external world at all, but rather a fundamental structure of consciousness itself. We cannot conceive of experience without time, cannot imagine consciousness without the flow from past to future. Perhaps time is not something we discover in the universe, but something we bring to it, a lens through which consciousness makes sense of the eternal, timeless reality that underlies all existence. The contemplation of time leads us inevitably to questions of mortality and meaning. We are temporal beings, creatures born into time and shaped by its passage. Our lives have beginnings and endings, marked by the irreversible flow of moments that accumulate into experience, wisdom, and eventually memory. The awareness of our own mortality gives urgency to our choices, poignancy to our relationships, and depth to our search for meaning. Yet even as we are bound by time, we have the remarkable ability to transcend it through imagination, memory, and creativity. In dreams, we revisit the past and explore possible futures. In art, we capture moments and make them eternal. In love, we experience glimpses of the timeless moments that seem to exist outside the normal flow of duration. In meditation and contemplation, we can touch something that feels beyond time, a stillness that underlies all change, a presence that gives meaning to all becoming. The great spiritual traditions of the world have always recognized this dual nature of time. They speak of chronos and kairos, of time as illusion and time as sacred, of the eternal present that underlies all temporal experience. They teach us that while we live in time, we are not merely creatures of time. There is something in us that partakes of the eternal, that can step outside the flow of moments and recognize the timeless awareness in which all experience arises. Modern physics has given us new metaphors for understanding this ancient wisdom. The block universe theory suggests that all moments, past, present, and future, exist simultaneously in the four-dimensional fabric of space-time. From this perspective, time is like a landscape through which consciousness moves, But the landscape itself is eternal and unchanging. Your birth and death, your first kiss and your last breath, all exist equally in the vast democracy of space-time, distinguished only by their location in the temporal dimension. This view of time as a dimension rather than a flow has profound implications for how we understand existence itself. If all moments exist equally, then in some sense, nothing is ever truly lost. Every experience, every relationship, every moment of beauty or sorrow is preserved forever in the structure of space-time. The past is not gone, but simply located elsewhere in the temporal landscape, as real and present as any other moment. As we stand at the threshold of the 21st century, our understanding of time continues to evolve. Quantum computers may soon allow us to explore the deepest mysteries of quantum mechanics, potentially revealing new aspects of time's nature. Advances in neuroscience are illuminating the mechanisms by which consciousness constructs temporal experience. Cosmologists are pushing back the boundaries of our understanding, revealing the history of time itself from the first moments after the Big Bang to the ultimate fate of the universe. The search for a theory of quantum gravity, which would unite Einstein's general relativity with quantum mechanics, may finally reveal the deepest nature of time. Some theories suggest that time itself might be quantized, composed of discrete units smaller than anything we can currently measure. Others propose that time might emerge from more fundamental quantum processes, like temperature emerging from the motion of molecules. The concept of time touches every aspect of human existence, from the biological rhythms that govern our bodies to the social structures that organize our societies. We live by schedules and deadlines, celebrate anniversaries and birthdays, mark the passage of seasons and years. We save for the future and reminisce about the past. We measure our lives in moments and memories, in the accumulation of experience that we call growing older. Yet for all our familiarity with time, it remains profoundly mysterious. We cannot say what time is, only what it does. We cannot step outside of it to examine it objectively, only experience it subjectively from within. We cannot control its passage or change its direction, only learn to move with its flow with greater wisdom and grace. Perhaps this is as it should be. Time is not merely a problem to be solved or a mystery to be unraveled, but a fundamental aspect of existence to be lived and experienced. It is the medium through which love grows, wisdom develops, and meaning unfolds. It is the canvas upon which we paint our lives, the rhythm to which we dance our brief participation in the cosmic symphony. As you sit here now, reading these words, you are embedded in time's flow. The neurons in your brain are firing in precise temporal patterns, creating the experience of understanding. Your heart is beating in steady rhythm, marking the passage of seconds with each pulse. Your cells are aging, your memories are forming, your future is approaching with each passing moment. This is time as we experience it, not as an abstract concept, but as the very medium of existence itself. It is the stage upon which the drama of consciousness unfolds, the river in which we swim, the air that we breathe. We are temporal beings, creatures of time, and our deepest understanding of existence must therefore be temporal as well. The concept of time remains one of humanity's greatest intellectual adventures, a journey that has taken us from ancient sundials to atomic clocks, from mythological cycles to relativistic physics, from the mechanical universe of Newton to the quantum mysteries of the modern age. As we drift deeper into the mystery of time itself, we find ourselves at the threshold of consciousness, where the objective tick of cosmic clocks meets the subjective experience of living, breathing, feeling beings. This is perhaps the most intimate aspect of time's nature, the one we know most personally yet understand least clearly. Your brain, that 3-pound universe nestled within your skull, is constantly constructing time. not measuring it, not simply perceiving it, but actively creating your experience of temporal flow. Every moment you live is a masterpiece of neural architecture, where millions of neurons coordinate to weave the threads of past, present, and future into the seamless tapestry of consciousness. Consider how effortlessly you navigate through time in your daily life. You remember what you had for breakfast, you experience the present moment of reading these words, and you anticipate what might come next. This seems natural, obvious even, yet it represents one of the most sophisticated information processing systems in the known universe. Your brain is simultaneously a time machine, a recording device, and a prediction engine, all wrapped into one extraordinary biological computer. The construction of temporal experience begins in the most fundamental processes of neural activity. Individual neurons fire in patterns that create rhythms, and these rhythms interact with other rhythms to form the complex symphony of brain activity. Some neurons fire every few milliseconds, others cycle over seconds or minutes, and still others participate in rhythms that span hours or even days. This intricate network of biological clocks creates the foundation upon which your experience of time is built. But consciousness does something remarkable with these neural rhythms. It takes the raw material of brain activity and transforms it into something entirely new, a sense of temporal flow that seems to move from past through present toward future. This isn't simply a passive recording of events, but an active construction of meaning, where your brain constantly weaves together memory, sensation, and anticipation into a coherent narrative of experience. The relationship between brain activity and time perception reveals itself most clearly when things go wrong. During moments of extreme stress or danger, time seems to slow down dramatically. Athletes speak of being in the zone, where everything moves in slow motion and they have all the time in the world to react. Accident victims often report that time stretched out during their crash, allowing them to observe every detail with crystal clarity. These aren't illusions or tricks of memory, but genuine alterations in how consciousness constructs temporal experience. Your brain achieves this temporal flexibility through an intricate process of attention and memory formation. When you're fully focused, when your attention is completely engaged, your brain processes information at a much higher resolution. It captures more details, notices more patterns, and creates richer memories. Later, when you recall these moments, the wealth of information makes them feel as if they lasted longer than they actually did. It's as if consciousness has a zoom function, able to slow down and examine experience in exquisite detail when circumstances demand it. This same principle works in reverse during periods of routine or boredom. When you're going through familiar motions, when your attention is elsewhere, your brain processes information at a much lower resolution. It captures fewer details, notices fewer patterns, and creates sparser memories. These periods seem to pass quickly in the moment, but leave little trace in memory. Hours can slip by unnoticed, days can blur together, and weeks can feel like they've vanished without a trace. The emotional coloring of experience also profoundly influences temporal construction. Moments of joy seem to expand, creating memories that feel rich and full and timeless. Periods of suffering, paradoxically, can feel both endless in the moment and surprisingly brief in retrospect. Love has its own temporal signature, creating memories that feel both eternal and fleeting, moments that seem to exist outside the normal flow of time altogether. Memory itself is far more than a simple recording device. It's an active, creative process that reconstructs the past every time you remember it. Each memory is a new construction, influenced by your current state of mind, your emotions, and your accumulated life experience. This means that your past is constantly being rewritten, that the history you carry within you is as much a creation of the present moment as it is a record of what actually happened. The future, too, is an active construction of consciousness. Your brain is constantly generating predictions, creating models of what might happen next, based on patterns it has learned from the past. These predictions aren't just cognitive exercises, they're integral to how consciousness creates the sense of temporal flow. The future pulls you forward, creating a sense of direction and purpose that gives shape to the present moment. This predictive aspect of consciousness reveals something profound about the nature of time and awareness. You don't simply exist in the present moment. You exist in a kind of temporal bubble that extends into both past and future. Your consciousness is always leaning forward, always anticipating, always preparing for what comes next. This creates a sense of temporal momentum that carries you through life, a feeling that time is flowing even when nothing seems to be happening. The construction of temporal experience also involves a constant process of calibration and adjustment. Your brain is continuously comparing its internal clocks to external rhythms, adjusting its sense of time based on cues from the environment, the rising and setting of the sun, the rhythm of meals, the social patterns of work and rest. All of these help to synchronize your internal experience of time with the world around you. But consciousness can also override these external cues, creating its own temporal reality. During periods of deep focus or creative flow, hours can pass unnoticed. In meditation or contemplation, the ordinary sense of time can dissolve entirely, leaving only the eternal present moment. These experiences reveal that consciousness has remarkable flexibility in how it constructs temporal experience, that the sense of time's passage is far more malleable than we typically realize. The social dimension of time construction adds another layer of complexity to the picture. Human consciousness didn't evolve in isolation, but in the context of social groups, where coordinating activities and sharing experiences was essential for survival. This social aspect of time creates shared temporal rhythms that bind communities together. The weekly cycle of work and rest, the seasonal celebrations, the daily rhythms of social interaction, all of these create collective temporal experiences that shape individual consciousness. Language itself is deeply intertwined with temporal construction. The words you think, the stories you tell yourself, the way you narrate your experience, all of these linguistic processes help to create the sense of temporal flow. Different languages construct time differently, some emphasizing the cyclical nature of experience, others the linear progression from past to future. The words you have available to describe temporal experience actually influence how you experience time itself. As we explore the relationship between consciousness and time, we encounter one of the deepest mysteries of existence. How does subjective experience arise from objective neural activity? How does the felt sense of temporal flow emerge from the complex dance of brain chemistry and electrical activity? These questions touch the very heart of the mind-body problem, the relationship between the physical and the mental, the objective and the subjective. What we can say with certainty is that consciousness and time are intimately connected, that the experience of being aware is inseparable from the experience of temporal flow. Every moment of consciousness is a moment in time. Every memory is a bridge to the past. Every anticipation is a reach toward the future. Consciousness doesn't just exist in time, it actively participates in the construction of temporal experience. As you continue to explore the nature of time and consciousness, remember that you are not just an observer of these processes, but an active participant in them. Your awareness, your attention, your memory, your anticipation, all of these are continuously shaping your experience of time. In every moment, you are both the author and the reader of your own temporal story, creating the very experience of time that you seek to understand. The relationship between consciousness and time remains one of the most profound mysteries we face, a puzzle that bridges the gap between the physical and the mental, the objective and the subjective. Building on our exploration of time's fundamental nature, we now venture into one of the most fascinating frontiers where temporal mysteries converge with human understanding. The intersection of time, consciousness, and quantum mechanics represents perhaps the most intriguing puzzle in our quest to comprehend reality's deepest structures. In the quantum realm, time reveals behaviors that challenge our everyday intuitions. Quantum entanglement suggests that particles can share instantaneous correlations across vast distances, seemingly transcending the limitations that time ordinarily imposes. When two particles become entangled, measuring one immediately affects the other, regardless of the spatial separation between them. This phenomenon has led some physicists to propose that time, at its most fundamental level, might be an emergent property rather than a basic feature of reality. The concept of quantum superposition further complicates our understanding of temporal flow. Until observed, quantum systems exist in multiple states simultaneously, suggesting that the very act of measurement or observation plays a crucial role in determining reality's structure. This observation-dependent nature of quantum mechanics raises profound questions about the relationship between consciousness and time. Does consciousness somehow participate in the construction of temporal experience, or does it merely perceive a pre-existing temporal framework? Consider the puzzling nature of quantum tunneling, where particles appear to traverse barriers faster than light should allow. Some interpretations suggest that these particles experience time differently, or that time itself becomes malleable at quantum scales. These phenomena hint at a deeper reality, where the rigid, linear progression of time we experience might be merely a macroscopic approximation of something far more complex and fluid. The measurement problem in quantum mechanics introduces another temporal paradox. Before measurement, quantum systems evolve according to the deterministic Schrödinger equation, suggesting a universe where past, present, and future coexist in a superposition of possibilities. However, the moment we observe or measure a quantum system, this superposition collapses into a definite state, creating what appears to be a singular timeline. This transition from quantum indeterminacy to classical definiteness remains one of physics' most profound mysteries. Some interpretations of quantum mechanics, such as the many worlds theory, propose that time branches at every quantum measurement, creating infinite parallel timelines. In this view, consciousness doesn't collapse quantum superpositions, but rather selects which branch of reality to experience. This suggests that time might be fundamentally tree-like rather than linear, with countless possible futures coexisting until consciousness chooses a particular path through the quantum multiverse. The role of information in quantum mechanics also provides insights into time's nature. Quantum information theory suggests that the universe might be fundamentally computational, with time representing the flow of information processing. From this perspective, consciousness might be understood as a particular type of information processing system that creates temporal experience through its interactions with quantum information. Recent experiments in quantum mechanics have revealed even more puzzling temporal behaviors. Quantum erasure experiments demonstrate that future decisions can appear to retroactively influence past events, suggesting that causality itself might be more flexible than we assumed. These findings challenge our basic understanding of cause and effect, implying that time's arrow might not be as straightforward as classical physics suggests. The phenomenon of quantum coherence also reveals time's mysterious nature. Quantum systems can maintain coherent superpositions for extended periods, existing in states that transcend classical temporal limitations. Some researchers propose that consciousness itself might rely on quantum coherence, suggesting that our experience of time emerges from quantum processes in the brain. Theoretical physics has proposed various models for understanding time's quantum nature. Loop quantum gravity suggests that time itself might be granular, composed of discrete units, rather than flowing continuously. String theory proposes additional temporal dimensions beyond our familiar experience, suggesting that time might be far more complex than we can directly perceive. The concept of quantum time dilation introduces another layer of complexity. Just as massive objects create gravitational time dilation according to general relativity, quantum effects might create their own temporal distortions. Some theories suggest that consciousness, through its quantum interactions, might experience time differently than passive matter, creating subjective temporal experiences that diverge from objective physical time. These quantum perspectives on time intersect with neuroscientific findings about consciousness and temporal perception. The brain's neural networks create synchronized oscillations that might rely on quantum coherence to generate unified conscious experiences. Some researchers propose that consciousness emerges from quantum processes in microtubules within neurons, creating a bridge between quantum mechanics and subjective temporal experience. The implications of quantum temporal mechanics extend beyond physics into philosophy and spirituality. If time is indeed emergent from quantum processes, and if consciousness participates in these processes, then our subjective experience of time might be more fundamental than previously thought. This suggests that the distinction between objective and subjective time might be false, with consciousness playing an active role in constructing temporal reality. These quantum insights also illuminate the relationship between time and free will. If consciousness can influence quantum measurements, and if these measurements help construct temporal reality, then our choices might literally shape the flow of time. This perspective suggests that we are not passive observers of a predetermined timeline, but active participants in creating temporal experience through our conscious decisions. The integration of quantum mechanics with theories of consciousness offers new perspectives on time's deepest mysteries. Rather than viewing time as a container within which events occur, these approaches suggest that time emerges from the complex interactions between consciousness, quantum information, and physical processes. This view positions consciousness not as separate from physical reality, but as an integral component of the universe's fundamental structure. As we continue exploring these quantum frontiers, we discover that time's nature remains beautifully mysterious. The intersection of quantum mechanics, consciousness, and temporal experience reveals a universe far stranger and more wonderful than classical physics suggested. As we journey deeper into time's labyrinth, we encounter perhaps its most profound paradox, the arrow of time itself. While quantum mechanics whispers of temporal uncertainty and relativity demonstrates time's malleable nature, our lived experience remains stubbornly unidirectional. We remember the past, experience the present, and anticipate the future, yet never the reverse. This asymmetry, this cosmic preference for forward motion, emerges from one of the universe's most fundamental principles: entropy. Picture a drop of ink dissolving in clear water. The tendrils spread outward, creating beautiful swirling patterns as order transforms into chaos. You've never seen this process reverse spontaneously. Never watched scattered ink molecules suddenly organize themselves back into a perfect droplet. This isn't mere coincidence, but rather a manifestation of the second law of thermodynamics, which states that entropy, the measure of disorder in a closed system, always increases over time. Entropy provides time with its arrow, its direction, its irreversible flow from past to future. In the early universe, shortly after the Big Bang, matter and energy existed in a state of remarkable order. Particles were distributed with stunning uniformity, temperatures were consistent across vast distances, and the cosmos possessed what physicists call low entropy. But as the universe expanded and cooled, this pristine order began to decay. Gravity pulled matter together, forming the first stars and galaxies. Nuclear fusion ignited, converting hydrogen into heavier elements. Black holes formed, warping space-time itself. Each of these processes increase the universe's total entropy, creating the arrow of time we experience today. The stars that light our night sky are entropy engines, converting ordered nuclear fuel into disordered radiation and heat. The Earth's climate systems, driven by solar energy, create weather patterns that disperse heat from equator to poles. Even your morning coffee cooling on the kitchen table represents entropy in action, as organized thermal energy spreads into the surrounding air. But entropy's relationship with time runs far deeper than simple thermodynamics. It influences the very structure of memory, consciousness, and causality itself. When you remember yesterday's events, you're accessing information that required energy to store and maintain. Your brain, that 3-pound universe of neural networks, operates as a sophisticated entropy processing system, constantly converting sensory data into memories, thoughts, and decisions. The formation of memories requires the creation of new neural pathways, the strengthening of synaptic connections, and the synthesis of proteins that encode information. Each of these processes increases entropy at the cellular level, even as they create the ordered structures we call memories. This is why forgetting feels natural while remembering requires effort. Your brain is constantly balancing the energy cost of maintaining memories against their utility, allowing unused information to decay while reinforcing patterns that serve survival and adaptation. This entropy-driven forgetting shapes not just individual consciousness, but collective human experience. Civilizations rise and fall partly because information degrades over time. Languages evolve as speakers unconsciously simplify complex grammatical structures. Cultural traditions fade unless actively maintained through repetition and ritual. Even our most permanent records, carved in stone or encoded in digital formats, require constant energy input to preserve them against entropy's relentless advance. The arrow of time also manifests in causality, the principle that causes precede effects. You can break a glass, but you cannot unbreak it. You can burn a photograph, but you cannot unburn it. This isn't merely a practical limitation, but a fundamental feature of how entropy organizes temporal experience. Causal relationships emerge from the statistical tendency of systems to move from order to disorder, creating the logical structure that underlies both physical law and human reasoning. Yet entropy's relationship with time contains surprising subtleties. While the universe's total entropy always increases, local pockets of order can emerge and persist. Life itself represents one such pocket, a temporary reversal of entropy's tide. Living organisms maintain their complex structures by consuming energy and exporting entropy to their environment. A growing tree converts sunlight and carbon dioxide into ordered cellulose and oxygen, creating local order at the expense of increasing the sun's entropy through nuclear fusion. This principle extends to human consciousness and culture. When you learn something new, you're creating order in your neural networks, reducing local entropy even as your brain's metabolic processes increase entropy elsewhere. When artists create beauty, when scientists discover natural laws, when communities build institutions, they're all participating in entropy's complex dance, creating islands of order in an ocean of increasing disorder. The arrow of time also influences how we understand the universe's ultimate fate. If entropy continues to increase indefinitely, the cosmos faces what physicists call heat death, a state of maximum entropy where all energy has been evenly distributed and no further work can be performed. In this far future, stars will exhaust their nuclear fuel, black holes will evaporate through Hawking radiation, and the universe will settle into a cold, uniform state of maximum entropy. But even this seemingly final endpoint contains mysteries. Some theories suggest that quantum fluctuations might occasionally decrease entropy in small regions, creating temporary pockets of order that could, given enough time, spontaneously generate new structures, new complexity, even new forms of consciousness. The universe might experience cycles of order and disorder, with entropy's arrow occasionally reversing direction on cosmic scales. Other theories propose that the universe's expansion itself might eventually reverse, creating a contracting cosmos where entropy decreases and time's arrow points backward. In such a scenario, the familiar sequence of cause and effect might invert, with broken glasses spontaneously reassembling and scattered ink droplets emerging from uniform solutions. These possibilities remain highly speculative, but they highlight how entropy's relationship with time continues to challenge our understanding. Recent discoveries in quantum mechanics and cosmology have revealed that time's arrow might not be as absolute as once believed. Quantum systems can exhibit temporal correlations that seem to violate classical causality, suggesting that the microscopic world operates according to different temporal rules than the macroscopic realm we inhabit. The study of entropy has also revealed deep connections between time, information, and consciousness. Information theory, developed by Claude Shannon in the mid-20th century, treats information as a form of negative entropy, a measure of order that can be transmitted, stored, and processed. This mathematical framework has revolutionized our understanding of everything from computer science to biology, revealing that the flow of information might be as fundamental to time's arrow as the flow of energy. Your consciousness, in this view, represents a complex information processing system that creates temporal experience through the constant integration and organization of sensory data. The stream of consciousness, that continuous flow of thoughts and perceptions that defines your inner life, emerges from your brain's ability to process information faster than entropy can destroy it. This creates the subjective experience of time's passage, the feeling that moments succeed one another in orderly progression. But consciousness also shapes time's arrow through memory and anticipation. Your ability to remember the past and imagine the future creates a temporal landscape that extends far beyond the present moment. This cognitive time travel allows humans to learn from experience, plan for contingencies, and create cultural institutions that persist across generations. In a sense, consciousness amplifies time's arrow, transforming the simple thermodynamic principle of increasing entropy into the rich temporal experience that defines human existence. The arrow of time also influences how we understand free will and moral responsibility. If the future is determined by the past through the inexorable increase of entropy, what room exists for genuine choice and agency? This question has puzzled philosophers and scientists for centuries, creating ongoing debates about determinism, randomness, and the nature of human freedom. Some argue that quantum mechanics introduces genuine randomness into the universe, creating space for free will within the gaps of deterministic law. Others contend that consciousness itself represents a form of temporal agency, a way of organizing information that allows minds to influence the future through intention and choice. Still others suggest that free will might be an illusion created by the complex information processing systems we call brains, a useful fiction that helps us navigate social relationships and moral decisions. These debates remain unresolved, but they highlight how entropy's arrow shapes not just physical processes, but the deepest questions about human existence. The irreversible flow of time creates the context within which we make choices, form relationships, and create meaning. Without entropy's arrow, there would be no growth, no learning, no progress, no hope for the future. As we contemplate time's arrow, we're forced to confront our own mortality and the temporary nature of all human achievements. The entropy that drives time's passage also ensures that nothing lasts forever. Stars burn out, mountains erode, civilizations crumble, and even the most permanent human creations will eventually succumb to time's relentless advance. This recognition of impermanence has shaped human culture throughout history, inspiring art, religion, and philosophy that grapple with the meaning of existence in a world defined by temporal flow. Yet entropy's arrow also creates the possibility of genuine novelty and creativity. The increase of entropy doesn't simply destroy order, it also creates new forms of complexity that couldn't exist in a perfectly ordered universe. The random motion of molecules enables chemical reactions that build complex organic compounds. The chaotic dynamics of weather systems create the diverse climates that support life's incredible diversity. The entropy-driven evolution of species generates forms of beauty and intelligence that exceed anything imaginable in a static, perfectly ordered world. This creative aspect of entropy suggests that time's arrow might not be merely destructive but fundamentally generative, constantly creating new possibilities for order, complexity, and meaning. The universe's journey from simple uniformity to complex diversity represents not just the triumph of disorder over order, but the emergence of new forms of organization that transcend the simple categories of entropy and negentropy. Human consciousness itself might represent the universe's most sophisticated response to entropy's challenge, a way of creating meaning and purpose within the flow of time. Through art, science, love, and countless other expressions of human creativity, we participate in the cosmic dance between order and chaos, temporarily reversing entropy's tide while contributing to the larger pattern of cosmic evolution. The arrow of time, driven by entropy's relentless increase, thus emerges not as a constraint, but as the fundamental creative principle that makes possible everything we value about existence. Without time's forward flow, there would be no growth, no discovery, no relationships, no stories to tell about the universe's extraordinary journey from simplicity to complexity. Welcome to this gentle exploration of time, where we'll drift together through one of existence's most profound mysteries. As you settle into this quiet moment, wherever you are in the world, know that you're participating in something remarkable, the very phenomenon we're about to explore. Time flows around us like an invisible river, carrying us forward through each breath, each heartbeat, each passing thought. Yet for all its intimate presence in our lives, time remains one of the deepest puzzles in all of science and philosophy. Tonight, we'll let our minds wander through the corridors of temporal understanding, from the ancient wisdom of civilizations past to the cutting-edge discoveries of modern physics. Picture yourself floating gently through the dimensions of time itself. Feel how it moves beneath you, supporting you like warm water, while we explore its secrets together. Whether you're listening in the quiet hours before dawn, during a peaceful afternoon, or as evening settles into night, you're experiencing time's passage in this very moment, part of the eternal dance between past, present, and future. Before we begin this journey proper, I'd love to know where you're listening from and what time it is in your corner of the world. There's something beautifully fitting about contemplating time while we're all scattered across different time zones, each of us experiencing our own unique slice of now. If you find comfort in these gentle intellectual wanderings, please consider subscribing. It helps other curious minds discover this peaceful corner of contemplation. The story of time begins not with clocks or calendars, but with consciousness itself. Long before humans could measure time, they felt it in the rhythm of their hearts, the cycle of sleep and waking, the slow turning of seasons. Ancient civilizations recognized two distinct phases of time, each as essential as breathing itself. The Greeks called the first chronos, time as we typically think of it, measured and mechanical. Chronos is the time of clocks and schedules, of seconds ticking by with metronomic precision. It's linear, quantifiable, and relentless in its forward march. But there was also kairos, time as experienced, time as meaning. Kairos is the perfect moment, the right time, the temporal space where significance blooms. It's the time of inspiration, of connection, of those precious moments when everything seems to align. Even now, as you listen to these words, you're experiencing both. Chronos marks the minutes passing, but Kairos creates the space for understanding, for the gentle settling of ideas into consciousness. This duality has shaped human understanding of time for millennia, and it continues to influence how we perceive temporal reality today. Ancient cultures developed increasingly sophisticated ways of tracking time's passage. The Egyptians watched the stars wheel overhead, noting how certain constellations appeared and disappeared with the seasons. They created some of the first calendars, dividing the year into months and days with remarkable precision. The Mayans went further still, developing complex mathematical systems to track multiple cycles of time simultaneously: solar years, lunar months, and vast cosmic cycles spanning thousands of years. But it was the medieval monasteries that began to regularize time in ways that would eventually lead to our modern understanding. The need to coordinate prayers throughout the day and night led to the development of increasingly accurate timepieces. Water clocks gave way to mechanical clocks, and with them came a new relationship to time, one where human activity became synchronized to external temporal markers rather than internal rhythms. This mechanization of time reached its philosophical peak with Sir Isaac Newton in the late 17th century. Newton conceived of time as absolute, a cosmic river flowing uniformly throughout the universe, independent of matter or motion. In Newton's vision, time was like a vast stage upon which the drama of existence played out, but the stage itself remained unchanging and eternal. This absolute time ticked away with perfect regularity. The same for an ant crawling across a garden path as for a distant star burning in the depths of space. For over 2 centuries, this Newtonian view dominated scientific thinking. Time was universal, mechanical, and separate from the physical world it contained. But as the 19th century drew to a close, subtle cracks began to appear in this temporal edifice. Strange new phenomena were being discovered. The speed of light appeared to be constant regardless of the motion of its source, and certain experiments suggested that time might not be as absolute as Newton had imagined. Then, in 1905, a young patent clerk named Albert Einstein published a paper that would revolutionize our understanding of time forever. Special relativity revealed that time is not absolute but relative, intimately connected to space and motion in ways that defied common sense. Time, Einstein showed, could stretch and compress depending on how fast you're moving relative to something else. Travel near the speed of light, and time dilates, slowing down relative to those you've left behind. But Einstein wasn't finished. 10 years later, his theory of general relativity revealed an even more startling truth. Time is woven together with space into a single fabric called space-time, and this fabric can be warped and curved by matter and energy. Near massive objects, time runs slower. In the depths of a gravitational well, seconds stretch into longer intervals, compared to the flow of time in weaker gravitational fields. This isn't just theoretical abstraction, it's measurable reality. The GPS satellites orbiting our planet must account for relativistic effects, their clocks running slightly fast relative to Earth-bound timepieces due to both their motion and their position in Earth's gravitational field. Without these corrections, our navigation systems would drift by miles each day. Einstein's revelations opened new vistas of temporal possibility. If time could be stretched and compressed, if it was relative rather than absolute, then perhaps the rigid distinction between past, present, and future was itself an illusion. This brings us to one of the most profound mysteries in all of physics, the arrow of time. While Einstein's equations treat time as a dimension much like space, capable of being traversed in either direction, our experience of time is unidirectional. We remember the past, but not the future. We age, but never grow younger. Broken glasses don't spontaneously reassemble themselves. There's a clear arrow pointing from past to future, but where does this arrow come from? The answer lies in entropy, the measure of disorder in a system. The second law of thermodynamics tells us that in any isolated system, entropy tends to increase over time. Order spontaneously gives way to disorder, but never the reverse. This isn't just a statement about physics, it's a fundamental principle that defines the very nature of temporal flow. Consider a drop of cream swirling into coffee. The cream starts as a distinct, ordered structure, but it gradually disperses, creating an ever more random pattern until it's uniformly mixed throughout the liquid. This process is irreversible. You'll never see the cream spontaneously separate back into its original drop. The increase in entropy provides the arrow that distinguishes past from future. This entropic arrow of time has profound implications for everything from the formation of memories to the evolution of the universe itself. Memories are possible because our brains can encode information about lower entropy past states, but the high entropy future remains unknown and unpredictable. The universe began in a state of extraordinarily low entropy, a hot, dense, highly ordered condition we call the Big Bang, and it has been evolving toward higher entropy ever since. Stars form, burn, and die, converting ordered nuclear fuel into disordered radiation. Galaxies collide and merge, their organized structures eventually giving way to the heat death of the universe, when all available energy has been distributed evenly and no further work can be done. This cosmic increase in entropy provides the ultimate arrow of time, stretching from the ordered beginning of the universe to its disordered end. But even as we understand time's arrow through entropy, quantum mechanics introduces new puzzles about time's fundamental nature. In the quantum realm, particles exist in superposition, simultaneously in multiple states until measured. The act of measurement appears to collapse this superposition, selecting one outcome from many possibilities. But this raises profound questions about the nature of temporal flow at the quantum level. Some interpretations of quantum mechanics suggest that all possible outcomes of quantum events actually occur, branching into parallel timelines in an ever-expanding multiverse. Others propose that time itself might be emergent, not fundamental, but arising from more basic quantum processes. Still, others suggest that the flow of time might be intimately connected to the growth of quantum entanglement throughout the universe. These quantum mysteries remind us that despite centuries of progress in understanding time, we may still be far from grasping its deepest nature. Time remains simultaneously the most familiar and most mysterious aspect of existence, the stage upon which our lives unfold, yet perhaps the greatest enigma in all of science. As you drift towards sleep tonight, carried forward by time's gentle current, remember that you are part of this grand temporal tapestry. Your consciousness experiences the flow of moments. Your memories preserve the past, and your dreams perhaps offer glimpses of futures yet to unfold. The atoms in your body have journeyed through billions of years of cosmic time, and the thoughts in your mind participate in the same temporal dance that governs galaxies and quantum particles alike. Time cradles you as surely as it cradles the universe itself, and in the morning, when you wake to find that time has carried you safely through another night, you'll be witnessing the same mysterious flow that has puzzled philosophers and physicists for millennia. Now we delve into perhaps the most profound territory of our temporal journey. The nature of time itself becomes our subject of inquiry. Having traced the threads of consciousness and culture, quantum mechanics and cosmology, we arrive at a place where the very concept we've been exploring reveals its deepest mysteries. Time, it appears, may be far more malleable than our everyday experience suggests. Consider this: every moment you experience as now is actually a construction of your nervous system, assembling sensory data from slightly different moments into a coherent present. The light reaching your eyes left its source nanoseconds ago, sounds arrive at different speeds, and your brain takes additional milliseconds to process these signals. What you call now is really a carefully orchestrated illusion, a temporal collage created by neural processes. But this is only the beginning of time's strangeness. Modern physics suggests that time might not flow at all in the way we imagine. Einstein's relativity revealed that simultaneity is relative. Events that appear simultaneous to one observer occur at different times for another observer moving at a different speed. This isn't just a theoretical curiosity, it's a fundamental feature of reality that affects everything from GPS satellites to particle accelerators. The block universe theory, emerging from Einstein's work, proposes that all moments, past, present, and future, exist equally. In this view, time doesn't flow like a river. Instead, it's more like a landscape where every point exists simultaneously. Your birth, your current moment of reading these words, and your eventual death all exist as permanent features of this four-dimensional space-time structure. The flow of time becomes not a property of the universe, but a feature of consciousness moving through this static temporal landscape. Yet quantum mechanics introduces another layer of temporal mystery. At the quantum scale, the very notion of a definite moment becomes fuzzy. Particles exist in superposition, occupying multiple states simultaneously until measured. The act of measurement doesn't just reveal a pre-existing reality, it participates in creating that reality. This suggests that the present moment, the boundary between past and future, might be fundamentally tied to consciousness and observation. Some interpretations of quantum mechanics even suggest that the future can influence the past. In delayed choice experiments, decisions made about how to measure a particle seem to retroactively determine what happened to that particle earlier. If such effects operate in the macroscopic world, they could imply that our current choices are somehow connected to past events in ways that challenge our linear understanding of causation. The arrow of time, our experience of time flowing from past to future, appears to be linked to the increase of entropy, the tendency of systems to become more disordered over time. Yet this raises profound questions. Why did the universe begin in such a highly ordered state? Is the arrow of time universal, or could there be regions of space-time where it points in different directions? Some cosmological models suggest that in a cyclic universe, the arrow of time might reverse during contraction phases, making endings become beginnings and causes become effects. Memory plays a crucial role in our construction of temporal experience. Your sense of personal continuity through time depends on memory linking past moments to present experience. But memory is notoriously unreliable, constantly reconstructing rather than simply retrieving past events. Each time you remember something, you're not accessing a stored file but recreating the memory based on current neural patterns. This means your past is continuously being rewritten by your present, making personal history a collaborative creation between past experience and present consciousness. The relationship between consciousness and time becomes even more intriguing when we consider altered states of awareness. During deep meditation, psychedelic experiences, or certain neurological conditions, people report profound alterations in temporal perception. Time might seem to stop, flow backward, or become completely meaningless. These experiences suggest that our normal temporal experience is just one possible configuration of consciousness, not an inevitable feature of reality. Dreams offer another window into time's malleability. In dreams, causality can flow in impossible directions. past and future can coexist, and entire lifetimes can be experienced in moments. The dreaming mind seems to operate by different temporal rules, perhaps revealing capacities for non-linear time experience that remain largely dormant in waking consciousness. Some philosophers and physicists have proposed that time might be emergent rather than fundamental. Just as temperature emerges from the motion of molecules, but doesn't exist at the molecular level, time might emerge from more fundamental processes that are themselves timeless. In this view, the flow of time would be like the wetness of water, a property that exists at one level of description, but not at more fundamental levels. The implications of time's potential non-fundamentality are staggering. If time is emergent, then questions about what existed before the Big Bang become meaningless, like asking what's north of the North Pole. The entire structure of causation, the foundation of scientific explanation, might need to be reconsidered. Yet this might also open new possibilities for understanding consciousness, free will, and the nature of existence itself. As we stand at this threshold of understanding, we confront the possibility that time, the seemingly most basic feature of existence, might be the deepest mystery of all. The moment you call now, as you read these words, exists at the intersection of physics and consciousness, objectivity and subjectivity, the universal and the personal. It's a moment that contains the entire history of the universe and potentially shapes its future, yet it feels as intimate and immediate as your own breath. Perhaps the greatest mystery is not what time is, but how consciousness and time are related. Are we temporal beings experiencing timeless reality, or timeless beings experiencing temporal reality? So we've seen how gravity weaves the cosmic web and orchestrates the dance of galaxies. But now we turn to something even more intimate and profound. Time itself becomes our companion in this exploration. For understanding time is perhaps the most essential key to unlocking the deepest mysteries of existence. Picture this moment as you listen to these words. You're experiencing something so fundamental, yet so elusive, that philosophers and scientists have pondered it for millennia. Time flows around you like an invisible river, carrying you from past to future, shaping every thought, every heartbeat, every breath. Yet what exactly is this force that seems to govern all of existence? We inhabit two different kinds of time simultaneously. There's chronos, the measured time of clocks and calendars, the mechanical progression of seconds and minutes that organizes our daily lives. But there's also kairos, the experienced time of consciousness, where moments can stretch into eternities or collapse into fleeting instants. A single kiss might feel like it lasts forever, while years of routine can blur together in memory like pages in a book riffled too quickly. The ancient Greeks understood this duality intuitively. Kronos was the god of sequential time, the titan who devoured his children one by one, representing time's relentless forward march. Kairos was the god of the supreme moment, the perfect instant when all possibilities converge. In our modern world, we've become so focused on chronos that we sometimes forget the profound reality of kairos, the way consciousness shapes our experience of temporal flow. But time is far stranger than even the Greeks imagined. Einstein showed us that time isn't the absolute universal backdrop that Newton envisioned. Instead, it's woven into the very fabric of reality alongside space, creating what we call space-time. This four-dimensional continuum can be stretched, compressed, and warped by mass and energy. Time literally runs slower in stronger gravitational fields and at higher speeds. A clock on a mountaintop runs slightly faster than one at sea level. Astronauts returning from space have aged microseconds less than they would have on Earth. This isn't just theoretical physics, it's the lived reality of our universe. GPS satellites must account for these relativistic effects, adjusting their clocks to compensate for the time dilation they experience in Earth's weaker gravitational field. Without these corrections, our navigation systems would be off by miles within hours. Time, it turns out, is not the steady metronome we once believed it to be, but a dynamic, flexible dimension that responds to the presence of matter and energy. The arrow of time emerges from entropy, the universe's tendency toward increasing disorder. In the early cosmos, matter was distributed with remarkable uniformity, representing a state of extremely low entropy. As the universe evolved, gravity pulled matter together into clumps, forming stars and galaxies, while the expansion of space created ever larger voids between them. This process increases the total entropy of the universe, creating the thermodynamic arrow of time that gives us our sense of past and future. Yet even this arrow of time becomes mysterious when we examine it closely. The fundamental laws of physics are largely time-symmetric. The equations that describe electromagnetic forces, nuclear interactions, and even much of quantum mechanics work equally well, whether time flows forward or backward. It's only through statistical mechanics and thermodynamics that we recover the arrow of time, suggesting that our experience of temporal flow might be more about probability and information than about the fundamental nature of reality itself. Memory and anticipation create our psychological arrow of time. We remember the past with varying degrees of clarity, while the future remains uncertain, a realm of possibilities rather than fixed facts. This asymmetry in our knowledge creates the subjective experience of time's passage, even if the underlying physics suggests a more complex picture. The brain constructs our sense of temporal flow from countless neural processes, creating the illusion of a unified stream of consciousness moving through time. But quantum mechanics introduces even deeper mysteries about the nature of time. In the quantum realm, particles exist in superposition, embodying multiple states simultaneously until the moment of measurement collapses them into definite properties. This suggests that the classical notion of definite events occurring at specific moments in time might be an approximation that emerges from the quantum substrate of reality. Some interpretations of quantum mechanics suggest that all possible histories of the universe exist simultaneously, with our experience of a single timeline being just one thread in an infinite tapestry of parallel realities. The measurement problem in quantum mechanics raises profound questions about the relationship between time and consciousness. Does the act of conscious observation somehow select which quantum possibilities become real? If so, consciousness might play a fundamental role in the unfolding of time itself, making the observer an active participant in the creation of temporal reality rather than a passive witness to its flow. Quantum entanglement challenges our understanding of simultaneity and causality. When two particles become entangled, measuring one instantly affects the other, regardless of the distance between them. This non-local connection seems to transcend the limitations of space-time, suggesting that at the deepest level, reality might be more interconnected than our classical notions of space and time allow. Einstein called this spooky action at a distance, but subsequent experiments have confirmed that quantum entanglement is a genuine feature of our universe. Some physicists propose that time itself might be emergent rather than fundamental. Just as temperature emerges from the statistical behavior of countless molecules, time might emerge from more basic processes operating at the quantum level. This suggests that at the deepest level of reality, there might be no time at all, just timeless quantum processes that give rise to the temporal structures we experience. The block universe theory suggests that all moments in time exist simultaneously in a four-dimensional space-time block. Past, present, and future are all equally real, with our experience of temporal flow being an illusion created by our limited perspective. We're like readers moving through a book, experiencing the story sequentially, even though all the pages exist simultaneously. This view challenges our deepest intuitions about the nature of existence and free will. Yet consciousness remains the mystery within the mystery. How does the brain create the unified stream of awareness that experiences time's passage? Neural processes occur across multiple timescales, from millisecond action potentials to slower oscillations that coordinate different brain regions. The integration of these processes creates our sense of the specious present, the extended now that encompasses both immediate experience and short-term memory. Different states of consciousness alter our experience of time dramatically. In meditation, the sense of temporal flow can slow to a crawl or seemingly stop altogether. In dreams, time becomes fluid and nonlinear, with past and future events mixing freely. Psychedelic experiences can create profound alterations in temporal perception, sometimes giving access to what seems like eternal or timeless states of consciousness. As we drift deeper into this exploration of time, we encounter the possibility that our ordinary experience of temporal flow might be just one way of organizing reality. Perhaps consciousness and time are more intimately connected than we've imagined, with awareness itself being the bridge between the timeless quantum realm and the temporal world of classical experience. The mystery of time touches every aspect of existence, from the cosmic evolution of the universe to the fleeting moments of human consciousness. It connects the deepest questions of physics with the most intimate aspects of personal experience, suggesting that understanding time might be the key to understanding the nature of reality itself. In contemplating these mysteries, we find ourselves at the intersection of science and philosophy, of objective measurement and subjective experience, of the cosmic and the personal. Looking at our cosmic journey through time, we now arrive at perhaps the most profound chapter of all: how time itself becomes a mystery that deepens with every answer we discover. We've witnessed the birth of moments from quantum fluctuations, traced the arrow of time through entropy's patient work, and marveled at Einstein's revelation that time bends and flows like honey through the fabric of reality. Now, as we drift toward the conclusion of our temporal odyssey, we must confront the ultimate enigma. What happens when time itself becomes uncertain? When the very foundation of cause and effect begins to shimmer and dissolve like morning mist? In the quantum realm, that strange microscopic universe that underlies all reality, time behaves in ways that challenge our deepest intuitions about the nature of existence. Here, particles can exist in multiple states simultaneously, a phenomenon called superposition, where an electron might spin both clockwise and counterclockwise until the moment we observe it. But superposition isn't just about spatial properties, it extends to temporal ones as well. Quantum systems can exist in superpositions of different moments, different histories, different timelines all at once. Imagine, if you will, a quantum particle that encounters a fork in the road of space-time. In our everyday experience, it would choose one path or the other, creating a single timeline that unfolds into the future. But in the quantum world, the particle takes both paths simultaneously, existing in a ghostly superposition of all possible futures until something forces it to choose. This isn't science fiction. It's the fundamental nature of reality at its smallest scales, verified by countless experiments, and essential to technologies like quantum computers and atomic clocks. The implications of quantum superposition ripple outward from the microscopic realm into the very heart of our understanding of time itself. If particles can exist in multiple temporal states simultaneously, what does this mean for the arrow of time we've come to understand? The answer lies in a process called decoherence, where the quantum world's infinite possibilities gradually collapse into the single classical reality we experience. It's as if the universe is constantly choosing which timeline to follow. selecting one thread from the infinite tapestry of quantum possibilities. This selection process isn't random or arbitrary. It's guided by probability waves that ripple through the quantum foam of space-time, creating what physicists call the many worlds interpretation of quantum mechanics. In this view, every quantum measurement, every moment of decoherence, splits the universe into multiple branches, each representing a different possible outcome. We experience only one branch, one timeline, but countless others exist in parallel, each with their own version of history unfolding according to different quantum choices. The philosophical implications are staggering. If multiple timelines exist simultaneously, each as real as our own, then the past isn't fixed and immutable, but rather a collection of possibilities that have been actualized through quantum decoherence. The future isn't a single destination, but an infinite branching tree of potential realities, each waiting to be born through the next quantum measurement, the next moment of observation that collapses possibility into actuality. This branching structure of time creates what some theorists call a quantum multiverse, where every possible history exists somewhere in the vast landscape of parallel timelines. In some branches, the dinosaurs never went extinct. In others, you made different choices this morning, or gravity works slightly differently, or the speed of light has a different value. Each branch is equally real from the perspective of quantum mechanics, though we can only ever experience one thread in this infinite tapestry. But quantum mechanics offers us an even stranger possibility: quantum entanglement, where particles become connected across space and time in ways that seem to violate our understanding of causality. When two particles become entangled, measuring one instantly affects the other, regardless of the distance separating them. Einstein famously called this spooky action at a distance. But experiments have confirmed that entanglement is a genuine feature of quantum reality. Recent research suggests that entanglement might extend beyond space into time itself, creating what physicists call temporal entanglement. In this phenomenon, particles separated not just by distance, but by time itself remain connected, their quantum states intertwined across the temporal dimension. A measurement performed on a particle today might instantaneously affect the quantum state of a particle that existed yesterday or will exist tomorrow, creating causal loops that challenge our linear understanding of time's arrow. These temporal entanglements hint at a deeper truth about the nature of time, that past, present, and future might be more interconnected than we realize. Rather than a river flowing in one direction, time might be more like a vast ocean, where currents from different eras mix and mingle, creating eddies and flows that connect distant moments in ways we're only beginning to understand. The uncertainty principle, Werner Heisenberg's famous contribution to quantum mechanics, adds another layer to our temporal mystery. This principle states that we cannot simultaneously know both the exact position and momentum of a particle with perfect precision. The more accurately we measure one property, the more uncertain the other becomes. But the uncertainty principle extends beyond space and momentum to encompass time and energy as well. This temporal uncertainty means that the very notion of a precise moment becomes problematic at quantum scales. Events don't occur at exact instants, but rather within probability clouds of time, fuzzy temporal boundaries where cause and effect blur together. The shorter the time interval we try to measure, the more uncertain the energy involved becomes, creating virtual particles that pop in and out of existence like temporal ghosts haunting the quantum vacuum. These quantum fluctuations in time itself might be the key to understanding some of the deepest mysteries in physics. Some theories suggest that the Big Bang itself emerged from a quantum fluctuation in the vacuum of space-time, a moment when the uncertainty principle allowed something to emerge from nothing, creating not just space and matter, but time itself. 8 billion years of history might be the result of a quantum tunneling event through the barrier between non-existence and existence. The implications extend to the nature of consciousness and free will. If time is fundamentally uncertain at quantum scales, and if quantum effects influence the neural processes in our brains, then our thoughts and decisions might be connected to this deeper uncertainty in the fabric of reality. Perhaps consciousness itself is a quantum phenomenon, emerging from the collapse of temporal superpositions in the microtubules of our neurons, creating the subjective experience of now from the infinite possibilities of quantum time. This quantum perspective on time also offers new insights into the nature of memory and experience. Our memories aren't simply recordings of past events, but rather quantum reconstructions, probability distributions of what might have happened, filtered through the decoherence processes in our brains. Each time we remember something, we're essentially performing a quantum measurement on our own past, collapsing the superposition of possible memories into a single narrative thread. The phenomenon of quantum tunneling adds yet another wrinkle to our understanding of temporal causality. In tunneling, particles can pass through energy barriers that should be impossible to cross according to classical physics. But quantum mechanics allows for a small probability that a particle can borrow energy from the vacuum, tunnel through the barrier, and emerge on the other side. This process appears to happen instantaneously or even in negative time, creating paradoxes that challenge our understanding of causality. Some researchers have proposed that quantum tunneling might allow for closed time-like curves, loops in space-time where effect precedes cause. While such extreme scenarios remain highly speculative, they illustrate how quantum mechanics pushes the boundaries of our temporal understanding, suggesting that the linear flow of time we experience might be an emergent property of classical reality rather than a fundamental feature of the universe. The study of quantum time also reveals the deep connection between information and temporality. In quantum mechanics, information cannot be destroyed, only transformed and redistributed. This principle, known as unitarity, suggests that every quantum interaction preserves information about the past while generating new information about the future. Time becomes not just a dimension through which events unfold, but a process by which information is processed and transformed. This informational view of time connects to the holographic principle, which suggests that all the information in a volume of space can be encoded on its boundary. If time is fundamentally about information processing, then the flow of time might be equivalent to the flow of information from the quantum vacuum through the fabric of reality to the classical world we experience. Each moment becomes a frame in a vast computational process, reality itself emerging from the universe's ongoing calculation of its own quantum state. As we contemplate these quantum mysteries of time, we're forced to confront the possibility that our everyday experience of temporal flow might be a kind of cosmic illusion, a subjective phenomenon emerging from the interaction between consciousness and quantum decoherence. Perhaps the past, present, and future all exist simultaneously in the quantum multiverse, and our sense of moving through time is simply the result of our consciousness navigating through one particular branch of this infinite tree of possibilities. Yet even if time proves to be an illusion, it's an illusion that shapes every aspect of our existence. The quantum uncertainty that creates temporal superpositions also creates the space for novelty, creativity, and free will. The branching timelines of the multiverse provide infinite opportunities for growth, learning, and love. The temporal entanglements that connect distant moments also connect us to the deepest patterns of cosmic evolution, making us participants in the universe's ongoing exploration of its own possibilities. As you drift towards sleep tonight, carried by the gentle rhythm of quantum fluctuations in your neural networks, remember that you exist at the intersection of all these temporal mysteries. Your consciousness emerges from the collapse of quantum superpositions, Your memories are reconstructed from probability waves, and your dreams might be glimpses of parallel timelines where different possibilities have been actualized. You are not just in time, but made of time, woven from the same quantum threads that connect past, present, and future in the infinite tapestry of existence. The concept of time, as we've discovered, is far more than a simple dimension along which events unfold. It's the very fabric of reality, the stage upon which consciousness performs its cosmic dance, the medium through which the universe explores its own infinite potential. The fabric of reality, how time shapes everything. Time is perhaps the most familiar yet profoundly mysterious aspect of our existence. It flows through every moment of our lives, yet when we try to grasp its true nature, it slips away like water through our fingers. We feel its passage in our heartbeat, witness its effects in the changing seasons, and organize our entire existence around its steady march forward. But what is time, really? Is it the ticking of a clock, the aging of our bodies, or something far more fundamental woven into the very fabric of reality itself? Tonight, as we explore this most enigmatic dimension of existence, we'll journey through millennia of human understanding, from ancient philosophers who first wrestled with time's mysteries, to modern physicists who've discovered that time itself can stretch, compress, and even cease to exist under certain conditions. We'll uncover how time is intimately connected to space, energy, and consciousness itself, creating a tapestry of existence more intricate and beautiful than our ancestors could have ever imagined. The story of time begins not with clocks or calendars, but with the fundamental question of change itself. Long before humans developed sophisticated instruments to measure temporal intervals, our ancestors gazed up at the cycling moon, watched the sun trace its daily arc across the sky, and observed the endless rhythm of seasons. These natural cycles became humanity's first clocks, marking the passage of what we would eventually call time. Yet even in these earliest observations, a profound mystery emerged. Why does change occur in one direction and not another? Why do we remember the past but not the future? Why does a dropped vase shatter into pieces, but those pieces never spontaneously reassemble into a vase? The ancient Greeks were among the first to wrestle seriously with these questions, and their insights continue to shape our understanding today. They distinguish between two fundamentally different aspects of temporal experience: chronos and kairos. Chronos represented quantitative time, the measurable duration that could be divided into hours, days, and years. This was the time of commerce, agriculture, and civic life, the steady drumbeat that organized human society. Kairos, on the other hand, represented qualitative time, the right or opportune moment, the time of significance and meaning. It was the time of decision, of opportunity, of those moments when everything changes. This distinction reveals something profound about the nature of temporal experience. Time is not merely a container in which events occur, but an active participant in the drama of existence itself. As human civilization advanced, so did our ability to measure and manipulate time. The invention of mechanical clocks in medieval Europe represented a revolutionary shift in how we understood temporal flow. For the first time, time could be divided into precise, equal intervals, independent of the natural rhythms of day and night, season and weather. This mechanical time became the foundation of modern industrial society, allowing for the coordination of complex activities across vast distances and populations. Yet this triumph of precision came with a cost. The more accurately we could measure time, the more mysterious its fundamental nature became. The scientific revolution of the 16th and 17th centuries brought new tools and perspectives to the study of time. Galileo's experiments with falling objects revealed that time played a crucial role in the mathematical description of motion. His discoveries laid the groundwork for Isaac Newton's monumental synthesis, which would dominate our understanding of time for over 2 centuries. Newton conceived of time as absolute and universal, flowing uniformly throughout the universe like a great cosmic river. In this view, time was independent of space, matter, and motion, providing a fixed stage upon which the drama of physics unfolded. Every event in the universe could be assigned a precise temporal coordinate, and the simultaneity of distant events was an objective fact of nature. Newton's absolute time was more than a mathematical convenience. It reflected a deep philosophical commitment to the idea that the universe possessed an objective, unchanging structure. Time, in this conception, was like a divine clockwork, ticking away with perfect regularity, whether anything existed to experience it or not. This perspective proved remarkably successful in describing the motion of planets, the behavior of pendulums, and the countless mechanical devices that powered the Industrial Revolution. For centuries, Newtonian time seemed to capture something essential about the nature of reality itself. Yet even as Newton's framework achieved triumph after triumph, subtle anomalies began to accumulate. The speed of light, first measured with precision in the 19th century, seemed to be the same regardless of the motion of its source or observer. This strange constancy couldn't be explained within the framework of absolute time and space. Meanwhile, the study of heat and energy revealed that many processes in nature were irreversible, suggesting that time had an inherent direction that couldn't be captured by Newton's equations. These puzzles would eventually lead to one of the most profound revolutions in human understanding: the recognition that time itself is relative, malleable, and intimately connected to the structure of space and matter. The breakthrough came in 1905, when a young patent clerk named Albert Einstein published his special theory of relativity. Einstein's insight was both simple and radical. The speed of light in a vacuum is the same for all observers, regardless of their state of motion. This seemingly innocent statement had revolutionary implications for our understanding of time. If the speed of light is constant, then time itself must be relative. The duration of events depends on the relative motion of the observer. Time literally slows down for objects moving at high speeds, an effect that becomes dramatic as velocities approach the speed of light. This relativistic time dilation wasn't merely theoretical, it could be measured and verified. Atomic clocks flown on high-speed aircraft ran measurably slower than identical clocks left on the ground. Particles created in high-energy accelerators lived longer than expected when moving at relativistic speeds. Most remarkably, the global positioning system that guides our smartphones and navigation devices must account for relativistic effects to maintain accuracy. The satellites orbiting Earth experience time at a slightly different rate than we do on the surface, and without corrections based on Einstein's theory, GPS would accumulate errors of several kilometers per day. Einstein's general theory of relativity, published a decade later, revealed an even more profound truth about time's nature. Gravity, Einstein realized, wasn't a force in the traditional sense, but rather a curvature of space-time itself. Massive objects create depressions in the fabric of space-time, and what we experience as gravitational attraction is actually the tendency of objects to follow the straightest possible paths through this curved geometry. This geometric understanding of gravity had stunning implications for time. Just as motion affects the flow of time, so does gravity. Time runs slower in stronger gravitational fields, an effect that becomes extreme near massive objects like black holes. The merger of space and time into a unified space-time continuum represented one of the most profound shifts in human understanding since the Copernican revolution. Time was no longer the absolute, universal flow that Newton had envisioned, but rather a dimension of reality that could be stretched, compressed, and warped by matter and energy. the universe became a four-dimensional block, with past, present, and future existing as different regions of an eternal geometric structure. This block universe view suggests that all moments in time have equal ontological status. The past and future are as real as the present, differing only in their location within the temporal dimension. Yet even as relativity revealed the malleable nature of time, another revolution was brewing in the quantum realm. The study of atoms and subatomic particles revealed a world where the classical concepts of space and time seemed to break down entirely. Quantum mechanics introduced fundamental uncertainty into the description of physical systems, suggesting that the future might not be uniquely determined by the past. The act of measurement seemed to play a crucial role in determining the outcomes of quantum events, leading to paradoxes that challenged our understanding of causality and temporal sequence. Perhaps most mysteriously, quantum mechanics revealed phenomena that seemed to transcend the ordinary limitations of space and time. Quantum entanglement creates correlations between particles that persist instantaneously across arbitrary distances, appearing to violate the relativistic prohibition against faster-than-light communication. These quantum correlations exist outside the normal causal structure of space-time, suggesting that reality at its deepest level might not be constrained by the temporal ordering that governs our everyday experience. The intersection of quantum mechanics and relativity has led to even more radical questions about time's nature. Some interpretations of quantum mechanics suggest that time itself might be an emergent property, arising from more fundamental quantum processes, rather than being a basic feature of reality. In this view, the smooth flow of time that we experience might be an approximation, valid only at macroscopic scales, while the underlying quantum reality might be timeless or possess a fundamentally different temporal structure. These quantum mysteries have inspired speculation about the possibility of multiple timelines, parallel universes, and alternate histories. If quantum mechanics allows for multiple possible outcomes of any measurement, what happens to the alternatives that weren't observed? Some interpretations suggest that all possible quantum outcomes actually occur, but in separate branches of a vast multiversal tree. In this many-worlds picture, time becomes not a single thread, but a constantly branching network of possibilities, with our experience representing just one path through an infinite maze of potential realities. The study of consciousness adds yet another layer to time's mystery. Our subjective experience of temporal flow feels fundamentally different from the block universe of relativity or the timeless equations of quantum mechanics. We experience a vivid sense of the present moment, a flowing now that seems to move from past to future with inexorable momentum. This psychological time appears to be constructed by our brains through complex neural processes involving memory, attention, and anticipation. Different mental states can dramatically alter our perception of temporal flow. Minutes can feel like hours in moments of crisis, while hours can pass like minutes during engaging activities. The neural basis of time perception reveals a fascinating interplay between multiple brain systems. Circadian rhythms provide a biological clock that synchronizes our physiology with the daily cycle of light and darkness. Interval timing networks allow us to estimate durations and maintain temporal sequences. Memory systems create the continuity of experience that gives us a sense of personal history and identity. These systems work together to construct our subjective sense of time, but they can also be disrupted by injury, disease, or altered states of consciousness, revealing the constructed nature of temporal experience. The relationship between consciousness and time raises profound philosophical questions. Does consciousness create time, or does time create consciousness? Are we passive observers of temporal flow, or active participants in its construction? Some theories suggest that consciousness might be fundamental to time's nature, that the subjective experience of temporal becoming is what gives time its apparent direction and meaning. Others propose that consciousness is simply a complex information processing system that creates the illusion of temporal flow through its operation. The arrow of time, our sense that time flows from past to future, remains one of the deepest puzzles in physics and philosophy. While the fundamental laws of physics are largely time-symmetric, able to run equally well forward or backward, our experience of reality is profoundly asymmetric. We remember the past, but not the future. We observe systems evolving from order to disorder, but never the reverse, and we feel that we can influence future events but not past ones. This temporal asymmetry appears to be connected to the second law of thermodynamics, which states that entropy or disorder tends to increase over time in isolated systems. The thermodynamic arrow of time emerges from the statistical behavior of large numbers of particles. While individual particles follow time-symmetric laws, the collective behavior of many particles naturally tends towards states of higher entropy. This statistical tendency creates the irreversible processes we observe in nature. Heat flows from hot to cold, gases expand to fill their containers, and complex structures decay into simpler forms. The arrow of time thus appears to be a macroscopic phenomenon, emerging from the statistical behavior of microscopic systems, rather than being fundamental to the laws of physics themselves. This connection between time and entropy has profound implications for the history and future of the universe. The early universe appears to have been in a state of extremely low entropy, with matter and energy arranged in highly ordered configurations. The Big Bang represents not just the beginning of space and time, but the start of the cosmic process by which this initial order gradually transforms into the complex structures we observe today. Stars, planets, and life itself are temporary islands of order in the universal trend toward increasing entropy. The ultimate fate of the universe, according to current cosmological models, is a state of maximum entropy known as heat death. In this far future scenario, all available energy will have been converted into waste heat, all stars will have burned out, and all complex structures will have decayed. The universe will reach a state of thermal equilibrium where no further work can be extracted from the available energy. This represents the final victory of entropy over order, the ultimate expression of time's arrow pointing toward dissolution and decay. Yet even this bleak picture contains elements of mystery and possibility. The accelerating expansion of the universe, driven by dark energy, suggests that the cosmic story might be more complex than simple heat death. Quantum fluctuations in the vacuum might create new structures and possibilities, even in the far future. Some theories propose that the universe might be cyclic, with periods of expansion and contraction creating endless cycles of creation and destruction. Others suggest that the apparent heat death might be merely a phase transition, leading to new forms of order and complexity that we cannot currently imagine. The study of time also reveals deep connections to information and computation. The processing of information appears to require the irreversible destruction of other information, linking computation to the thermodynamic arrow of time. This connection suggests that time might be fundamentally about information processing, with the flow of time representing the universe's ongoing computation of its own future states. In this view, consciousness might be a particularly sophisticated form of information processing, creating the subjective experience of temporal flow through its operation. The digital revolution has created new metaphors and models for understanding time. Computer simulations can model the evolution of complex systems over vast temporal scales, revealing patterns and structures that would be impossible to observe directly. Virtual worlds create artificial temporalities with their own rules and rhythms. The internet has created a global information space where events can be recorded, transmitted, and accessed across vast distances almost instantaneously, creating new forms of temporal experience and coordination. These technological developments raise new questions about the nature of time and reality. If we can simulate complex systems with high fidelity, what distinguishes the simulated time from real time? If we can record and replay experiences, what does this mean for the uniqueness of temporal moments? If we can communicate instantaneously across the globe, how does this affect our sense of temporal and spatial connection? These questions become particularly acute as we develop more sophisticated virtual and augmented reality technologies that can create convincing simulations of temporal experience. The measurement of time continues to become more precise, with atomic clocks now achieving accuracies of better than 1 second in billions of years. This precision has revealed subtle effects that were previously unmeasurable, such as the gravitational redshift of light and the effects of Earth's rotation on the passage of time. These measurements have confirmed Einstein's predictions with extraordinary accuracy, while also revealing new puzzles about the nature of time and space. The search for a theory of quantum gravity, which would unify quantum mechanics with general relativity, may require a complete reconceptualization of time's nature. Some approaches suggest that time might be quantized, existing in discrete units, rather than flowing continuously. Others propose that time might be emergent from more fundamental quantum processes, with the smooth temporal flow we experience being an approximation valid only at macroscopic scales. Still, others suggest that time might be fundamentally relational, existing only in the context of interactions between quantum systems, rather than as an absolute background. The study of black holes has revealed particularly strange aspects of time's behavior. Near a black hole's event horizon, time dilation becomes extreme, with time appearing to slow to a crawl for distant observers. Inside the event horizon, the normal relationship between space and time breaks down entirely, with the singularity at the black hole's center representing a point where our current understanding of physics fails completely. The recent discovery of gravitational waves from merging black holes has opened new windows into these extreme regimes where time and space behave in ways that challenge our intuition. The possibility of time travel, long relegated to science fiction, has become a subject of serious scientific investigation. While travel to the past appears to be prohibited by various physical constraints, travel to the future is not only possible, but routinely achieved through relativistic effects. Astronauts returning from the International Space Station have aged slightly less than they would have on Earth's surface, making them literal time travelers to the future. More exotic possibilities, such as closed time-like curves created by rotating black holes or hypothetical wormholes, remain subjects of theoretical speculation. The anthropic principle raises questions about whether the apparent fine-tuning of physical constants, including those that govern time's behavior, might be necessary for the existence of observers like ourselves, if the flow of time was significantly different, if entropy behaved differently, or if the fundamental constants had different values. Would complex structures like stars, planets, and life be possible? This perspective suggests that our existence might place constraints on the possible nature of time and the universe more generally. The study of time intersects with questions of free will and determinism. If the future is as real as the past, as suggested by the block universe view, what does this mean for our sense of agency and choice? If quantum mechanics introduces genuine randomness into physical processes, does this provide room for free will, or does it simply replace determinism with chance? These questions touch on fundamental issues of human responsibility and meaning that have been debated by philosophers for millennia. The experience of time varies dramatically across different cultures and historical periods. Some cultures conceive of time as cyclical rather than linear, with events repeating in endless cycles of creation and destruction. Others view time as a spiral, combining linear progress with cyclical return. Modern industrial society has created increasingly precise and standardized temporal frameworks, but these may not capture the full richness of human temporal experience. The study of how different cultures understand and organize time reveals the extent to which our temporal concepts are shaped by social and cultural factors. The aging process provides a personal dimension to time's mystery. Our bodies serve as biological clocks, accumulating damage and changes that mark the passage of time. The study of aging reveals complex interactions between genetic programs, environmental factors, and stochastic processes that determine how we change over time. Recent research has identified cellular and molecular mechanisms of aging, raising the possibility that the aging process might be slowed or even reversed. This prospect raises profound questions about the relationship between biological time and personal identity. The development of life on Earth represents one of the most remarkable aspects of time's creative power. Over billions of years, simple chemical systems have evolved into the extraordinary complexity of living organisms. This evolutionary process demonstrates time's role as a creative force, capable of generating novelty and increasing complexity, despite the general tendency toward entropy. The emergence of consciousness represents a particularly significant milestone in this temporal development, creating beings capable of reflecting on time's nature and their place within it. The study of cosmology reveals time's role in the largest scale structures and processes in the universe. The cosmic microwave background provides a snapshot of the universe when it was only 380,000 years old, revealing the initial conditions from which all current structure evolved. The observation of distant galaxies allows us to look back in time, seeing the universe as it was billions of years ago. These observations reveal a universe that has been evolving and changing throughout its history, with time playing a crucial role in the development of cosmic structure. The possibility of multiple universes, suggested by various theories in cosmology and quantum mechanics, raises questions about whether time might be different in other cosmic domains. If there are regions of reality with different physical laws or constants, they might also have different temporal structures. Some theories suggest that time itself might have begun with the Big Bang, while others propose that time might be eternal, with our universe representing just one phase in an endless temporal process. The intersection of time with information theory has led to new insights about the nature of temporal processes. The concept of computational irreversibility shows that certain computational processes cannot be reversed without destroying information, creating a connection between computation and time's arrow. This perspective suggests that the universe might be understood as a vast computational system, with time representing the ongoing processing of information about its own states. The study of complex systems has revealed how temporal patterns can emerge from the interactions of many simple components. These emergent temporal behaviors, such as synchronization, oscillation, and chaos, demonstrate that time can exhibit rich and complex structures even in systems governed by simple rules. The study of these temporal patterns has applications ranging from understanding brain rhythms to predicting market fluctuations, revealing the deep connections between time and complexity. The relationship between time and memory extends beyond individual consciousness to encompass the entire universe. The cosmic microwave background serves as a memory of the early universe, preserving information about conditions billions of years ago. The geological record provides a memory of Earth's history, while the fossil record preserves information about the evolution of life. In this sense, the universe itself might be understood as a vast memory system, with time representing the process by which information about the past is preserved and transformed. The quantum nature of time remains one of the deepest mysteries in physics. While quantum mechanics has been extraordinarily successful in describing the behavior of matter and energy, its relationship to time remains unclear. Some interpretations suggest that time might be quantized, existing in discrete units rather than flowing continuously. Others propose that time might emerge from more fundamental quantum processes. With the smooth temporal flow, we experience being an approximation valid only at macroscopic scales. The study of consciousness and time reveals the extent to which our experience of temporal flow is constructed by our brains. Neuroscience has identified multiple neural systems involved in time perception, from circadian rhythms that synchronize our physiology with daily cycles to interval timing networks that allow us to estimate durations. These systems can be disrupted by injury, disease, or altered states of consciousness, revealing the constructed nature of temporal experience. As we stand at the threshold of new discoveries about time's nature, we find ourselves in a position remarkably similar to that of our ancestors, who first gazed up at the cycling heavens and wondered about the nature of change and duration. Despite centuries of scientific progress, time remains fundamentally mysterious, challenging our deepest assumptions about the nature of reality. The questions we ask about time today, from the possibility of time travel to the role of consciousness in temporal experience, echo the same fundamental puzzles that have captivated human imagination throughout history. The mystery of time continues to inspire new theories, experiments, and philosophical reflections. As we develop more sophisticated tools for measuring and manipulating temporal phenomena, we may discover aspects of time's nature that we cannot currently imagine. The study of time connects us to the deepest questions about existence, consciousness, and our place in the cosmos. The nature of time. A final reflection. As we reach the end of our contemplation of time's mysteries, we find ourselves standing at the edge of an infinite question that has captivated humanity since consciousness first turned its gaze upon itself. We have journeyed through the corridors of physics and philosophy, through the laboratories of neuroscience and the expanses of cosmology, yet time remains as enigmatic as ever, perhaps even more so now that we understand the depth of what we do not know. The story we have traced is one of remarkable discovery and persistent mystery. From the ancient Greeks who first distinguished between chronos and kairos, we have watched our understanding evolve through Newton's clockwork universe to Einstein's relativistic cosmos, where time bends and warps like a river flowing through curved space. We have seen how quantum mechanics introduces uncertainty into the very fabric of temporal reality, suggesting that time itself might emerge from something more fundamental, more strange than we have yet imagined. Perhaps most fascinating is how this cosmic mystery intersects with the most intimate aspects of human experience. The time that flows through our consciousness, marked by heartbeats and memories, by anticipation and reflection, is somehow connected to the time that governs the dance of galaxies and the decay of particles. We are temporal beings in a temporal universe, yet the nature of that temporality remains one of the deepest puzzles in all of science and philosophy. The questions we have explored together reveal time's paradoxical nature. Is it fundamental or emergent? Does it flow, or is flow merely an illusion of consciousness? Are past, present, and future equally real, or does only the present moment truly exist? These questions touch the very heart of what it means to exist, to experience, to be conscious in a universe that seems to unfold according to laws we are only beginning to glimpse. Modern physics suggests that time might not be the simple, universal tick of a cosmic clock that Newton imagined. Instead, it appears to be woven into the very structure of reality, inseparable from space, matter, and energy. The thermodynamic arrow of time points toward increasing entropy, yet quantum mechanics hints at deeper symmetries and reversibilities that challenge our intuitive understanding of temporal direction. Meanwhile, the emergence of time from more fundamental quantum processes remains an active area of research, with theories suggesting that what we call time might arise from the entanglement of quantum information across vast networks of reality. The implications extend far beyond academic physics. If time is indeed emergent, if the present moment is all that truly exists, if the flow of time is a construction of consciousness rather than a feature of the universe itself, then our entire understanding of memory, identity, causation, and meaning must be reconsidered. We are not simply beings who exist in time, but beings whose very existence might be intimately connected to time's deepest mysteries. Yet perhaps the most profound realization is that time, whatever its ultimate nature, is the medium through which all experience unfolds. Every moment of joy and sorrow, every discovery and loss, every breath and heartbeat occurs within time's embrace. The love we feel, the beauty we perceive, the meaning we create, all emerge from the temporal flow of existence. Time is not merely a dimension to be measured or a puzzle to be solved, but the very condition that makes consciousness, relationship, and significance possible. As we stand at the threshold of new discoveries in quantum gravity, cosmology, and neuroscience, we can anticipate that our understanding of time will continue to evolve. Future theories may reveal time to be even stranger than we now imagine, perhaps showing us that it is not one phenomenon, but many. Not one dimension, but a complex structure of relationships between events, observers, and the quantum substrate of reality itself. The mystery of time ultimately reflects the mystery of existence itself. We are conscious beings who emerged from a universe that has been unfolding for nearly 14 billion years, yet we experience only the briefest moment of that vast temporal expanse. We are made of atoms forged in stellar cores billions of years ago, yet we live and love and dream in the fleeting present. We are part of a cosmos that may be eternal, yet our individual existence is measured in mere decades. In contemplating time, we confront the deepest questions about the nature of reality and our place within it. These questions may never be fully answered, but in asking them, we participate in the ongoing human endeavor to understand our universe and ourselves. Time remains a mystery, but it is a mystery that reveals as much about the wonder of existence as it does about the limits of our knowledge. The concept of time, in all its complexity and mystery, continues to unfold before us like a vast landscape that we are only beginning to explore. As we move forward into an uncertain future, we carry with us the accumulated wisdom of millennia of human inquiry, the tools of modern science, and the enduring questions that make us human. Time flows on, carrying us with it, and in that flow, we find not answers, but ever deeper questions, not certainty, but wonder, not conclusions, but the endless beginning of understanding. In the end, perhaps time's greatest gift is not the answers it provides, but the questions it inspires, not the mysteries it solves, but the mysteries it reveals. We are temporal beings in a temporal universe, forever seeking to understand the nature of the time that makes our very seeking possible. The dance between time and consciousness, between the cosmic and the personal, between the known and the unknown, continues to unfold in ways we cannot fully predict or comprehend. And in that unfolding, we find the essence of what it means to be human, to be conscious, to be alive in a universe where time itself remains the deepest mystery of all. So, what is time really? A ticking clock? A river that flows? Or something far stranger, something woven into the very fabric of the universe? We may not have all the answers, but maybe understanding the questions is enough. Thank you for letting this story keep you company, wherever you are in time and space. I hope you rest well tonight. I wish you a very good night. And until next time, this is Boring Science signing off. Cheers.